Slides dash 111.
I hear the barking. Is that Dave's dog?
Hello?
Hi, Dave.
Hey, Bruce. Things that worked yesterday are not working today.
Shall I try to share my slides?
I'm trying to share a Note Well slide.
Oh.
And it's in the data tracker, but not in Meet Echo. How is that possible? All right. That's fascinating.
Yeah, if you try again, now you should see these slides in the preloaded materials. I preloaded them for you.
Okay. Yeah, but I don't see, I don't know who you are, but you didn't. I'm not seeing my Note Well deck to open with.
Yeah, because I haven't preloaded all of them. Just give me a few seconds. By the way, you can do so by going to the settings. That's the second button from the right on the top of the screen, and then manage slides.
Second button from the right. Show of hands, meeting materials. Start the tour. Settings.
Yeah, settings. There, and then manage slides.
And thanks to be shared, data tracker meeting materials. No, well. Okay, interesting. Sorry about that.
Sure, no problem.
They were preloaded yesterday. Hold on here. Sorry, let me just throw this up there. Share.
Whoa, great!
So if you were here yesterday, welcome to the NFSV4 Working Group Part 2. This is IETF 111, in case you were unaware of where you were. We have gone through half the agenda. Sorry, Dave, I just want to get this out of the way because I got to Note Well. We have 4 remaining sections. To finish today, Chuck Lee will be leading most of them on signing RDMA over RPC over RDMA, docs, NFS version 4 enabling use of Quick, and discussion on future work. But what I didn't get to yesterday, we mentioned it in passing. When you signed up for the IETF virtual meeting, you will have passed through in the registration time the Note Well document, a reminder of IETF policies. These cover patents and code of conduct. And if you're unaware of them, please read the documents. They make for good reading. Participating in the IETF, you agree to follow IETF process policies. But the most important things, if you're aware that any IETF contribution is covered by patents or patent applications that are owned or controlled by you or a sponsor, you must disclose that fact or not participate in the discussion. And you are being recorded, written, audio, photograph records of the meetings may be made available, and the personal information that you provide the IETF will be handled in accordance with IETF privacy statement. And there are no blue sheets, I found out, because you're simply logging in, automatically adds you to the blue sheet. Any questions before I hand it over? How is that done, Dave? Okay. Chuck?
Can't
And
hear
by the
me.
way, I am taking notes with Etherpad. I sent out a link. It's on the meeting material site or in the agenda site. If you want to join in there and throw in notes, I think it allows multiple writers. Let me get out of here. Okay.
So I've requested to share my slides. And Brian, I need you to
Yeah,
mute.
sorry. I got it. Got it.
Thank you.
Thank.
I don't see the quick slides.
Let me, hold on. Mm-mm.
Yeah, but you'll need to mute, Brian, because there's an echo.
Sorry. Hold on, I gotta fix this thing for you. Okay, the quick slide should be there now.
Okay, great. I see them. I'm going to start with quick. I think that's where there's a lot of interest. Some of the other two slide decks that I have are probably less interesting to people, and so if I get through these now, then whoever's not really interested in the other stuff, yeah, I haven't started the slideshow yet. You should see them now. Anyway, I'm going to start with a quick first so that folks who are not interested in some of the other items can leave as they need to. So I'm just putting up the screens for people who don't know what quick is. I see Lars in the chat room. He can certainly correct me if I've gotten anything wrong, and I encourage him to speak up. But basically, this is a new transport in the same vein as UDP or TCP. It's a transport service. It's connection oriented. It has transport layer security built right into it. And it has some new features that we might be interested in using for RPC. So I'm going to talk a little bit about some of the issues that we think might come up, and then we'll finish with a discussion of how we think we want to approach building an RPC on quick transport and then NFS on quick. If there are no questions about what's on this slide, I can move on. We're not really clear about who wants RPC over quick now that we have TLS support for RPC. That's probably the main benefit that RPC would see with quick is a transport layer security. There are some other advantages as well. They might not be available immediately just because quick is not quite done yet. There's some extensions that are looking kind of interesting that might be interesting to RPC. We don't have stakeholders or interested parties who are grabbing our collars and rattling us and saying, you know, we got to have quick now. There is some interest from some areas of the Linux community that are very focused on SMB because Microsoft is focusing on SMB on quick. I think they are probably leapfrogging over SMB with TLS and they're going right to quick. So if anybody else knows of a very strong usage scenario for quick, a particular user who might have a use for it, please let us know. Post on the mailing list or mention it here in the chat room. So I'm kind of a quick newbie, but there are some things that we've sort of been looking at and salivating a little bit over. and I've listed them here on the slide. One of the things that Quick would provide us is having more than one reliable stream per connection. And in that way, we could probably separate the forward and reverse direction RPC transaction streams. So forward would be on one stream and reverse would be on another. We can also do things, clever things like creating more than one stream per connection, because each stream has its own head of queue blocking. So blocking on one stream would not block progress activity on another stream. So anyway, that's one of the technical details that we'll need to drill into on the mailing list as we drill into Quick a little deeper. Another thing that Quick might offer RPC is better loss recovery. Congestion detection and control is more robust than it is for TCP. I'm not sure that's all that interesting for NFS, just because that typically runs on data center networks. Originally, of course, 20 years ago, when we created NFSV4, we had the lofty goal of making NFS a wide area file system, and that's where this kind of advanced error and congestion detection and control might be advantageous as over wide area networks. Also, it's pretty well known that RPC SecGSS doesn't obscure the RPC headers. Those are in the clear. Once we have TLS or Quick with a transport layer security, we would be able to obscure the entire RPC requests. Each of them would be completely private. Well, and for TLS, we still have to have a TLS probe in the clear, and with Quick, TLS is built in, and so that wouldn't, the client wouldn't need to probe TLS. It would just be there. It's not opportunistic. It's always on. And the fact that it's always on is might be problematic for some folks, just because when they select Quick, they would see a pretty immediate loss in performance over TCP without transport layer security. So I think we have to set that expectation for people who want to see Quick in our RPC in our in-kernel consumers, is that Quick is going to have this performance hit to it pretty immediately. The other issue is a similar issue to the one we have with TLS, and that is that a lot of the mechanisms that we have are all in user space. We, for kernel consumers like in-kernel NFS, we need to do something about implementing Quick in kernel. I know Windows is ahead of us on this, way ahead of us on this, ahead of us meaning Linux. I'm speaking with my Linux developer hat on. So I don't know if someone else knows about the status of the in-kernel implementation in Linux. I don't think there is one today. The loss of performance, someone's asking in the chat room about loss of performance. The loss of performance is simply due to the fact that the traffic is encrypted. I'm not sure that answers your question, but you basically can't turn off the encryption. There's a significant, we know there's a significant performance issue with encryption. We know that from experience because GSS certainly has a cost, and our initial implementations for RPC with TLS have also demonstrated performance loss.
The question, Nick.
Nick, do you want to speak up?
Nick Banks from Microsoft, main developer for MSQuick, the library that Windows uses. When you're saying loss of performance, like, I'm asking specifically what the target network conditions are here, because if you're going over the internet, all tests we have, the internet is the limiting factor, not the CPU costs of encryption. So that's why I was asking, like, when you're talking about loss of performance here, what is the scenario that you expect to lose lose performance? Yes, CPU is spent on encryption, but that's not necessarily the bottleneck.
Certainly, in scenarios where you're talking about traditional gigabit Ethernet, we wouldn't expect that the encryption costs would be would overcome the rate the gigabit rate limit. But on faster networks, 10, 25, 40, 56, 100 gigabit, we think the CPU cost is going to be the limiting factor. I'm also a little concerned about scalability on the server side because the server is basically going to be spending a lot of time handling encryption and decryption for potentially thousands, tens of thousands of clients. So we think that's going to be an issue.
Okay, thank you. That makes sense. For a comparison number, we've seen single connection numbers of like 8 gigabit throughput with an encrypted quick connection.
Yeah, I mean, I'm talking about the exceptional, high performance cases at this point, and also I have to be honest, I don't have numbers. We're just looking at our experience with encrypted GSS. That's our basis for this prediction. There's some features that we're not really expecting much benefit, quick features that we're not expecting to benefit much from. One is zero RTT. Most RPC connections are long-lived, especially the NFS ones. Basically, the clients connect and they use as much of the connection as they can. And Nick has shared some performance data in the chat room if people are interested in that. There might be some benefit for situations where the client does some port mapping or other arcane things at the beginning of a connection, but after that, really, having a 2 or 3 handshakes instead of one is really not much different. So I don't think zero RTT is going to be especially interesting as it is for things like web client, where they're making lots of connections all at the same time over and over again. We also had a dream of being able to use datagrams in a reliable context, and Quick doesn't have reliable datagrams. It has an unreliable datagram extension that's in the works. So we're still going to need some record fragment framing that is similar to what we do with TCP streams. Of course, each stream on a Quick connection would have its own framing. So how do we make this happen in the working group? We think that having an RPC over Quick binding document that is very similar to what RFC 8166 does for our RDMA would be the place to start this effort. I'm sorry, I was just reading some comments in the chat room. And such a document would spell out the framing, basically, repeating the same description of the framing that we have for TCP. Just the single 32-bit word in front of each RPC record. We'd need to request appropriate net IDs. We have 2 for each of TCP, UDP, and RDMA, so we'd probably need something like Quick and Quick 6. We need to discuss the guidelines around how RPC consumers like NFS might want to use multiple streams on one connection. And then I mentioned the TI-RPC transport nomenclature at the bottom. I don't think the IETF has anything binding to say about those, but we have to do something that describes connections that allow multiple streams per connection. And maybe we just punt on that and say we're not going to comment, but I think for user space implementations that depend on the TI RPC API, we're going to have some thought behind that. We'll also need to have some language in it that describes some quick transport specific issues. Let me remind myself what's on this slide. Oh yeah, I was having a conversation with one of the SMB over quick engineers at a SNIA SDC a couple of years ago, and he was mentioning that because quick runs over UDP, there's going to have to be some discussion of how an NFS server that listens on UDP ports will be able to steer traffic to quick and UDP at the same time. I think that's just going to require some prototyping and then some language in the transport document that we come up with. We can reuse the some of the RPC with TLS specification, in particular the ALPN and certificate usage guidelines in that document would apply to Quick V1 as well, since Quick V1 uses the TLS V1.3 handshake protocol. That is something that we can reuse. And then probably in a separate document, we would discuss some of the things that are particular to NFS and its relations to the RPC transports that it runs on. As I've mentioned several times already, because we have multiple streams allowed per connection, we'll have to address that somehow for NFS. In particular for NFSV4 sessions. I think Lars mentioned that there can be 2 to the 62 streams per connection. We could probably set up an individual stream for each slot in a session, for example, if we wanted to do that. We'd have to answer some questions about what bind conda session does now that there are multiple streams in a connection. We also have this issue about NFSV4 requiring a server to drop the connection if it ever loses an RPC transaction. Clients depend on that. Would we change that to be like the server terminates a stream when it drops an RPC? We'll have to have some discussion around that to figure out exactly how a RPC transaction loss is signaled by servers on quick transports. We have the same class of authentication issues that we have with RPC with TLS, and I think that's already going to be dealt with in the security document that Dave's been working on. So I had a few questions for the working group as a whole. Do we have consensus to begin work on this? Maybe we need to take that to that question to the list, or we could do a quick poll here to see if there's anybody who opposes beginning work on RPC over quick. I also had a question that's really just due diligence, whether we need a charter update for the working group to work on RPC over quick. I thought the question was pertinent. Most of the folks I've talked to, or all the folks I've talked to, say that we probably do not need a charter update to proceed with this. So I'm interested in hearing any comments from folks on this on these process questions. Hearing no objections, I think we should probably go ahead with this work, and we'll need to assign milestones. Maybe we can do that on list. Go ahead, Zed.
Yes. So I think that was a very good presentation. At least for me, I see there are like a couple of questions, and I also see like answer to those questions. So I mean,
Brian, can you mute? Thank you.
yeah, there was some echo. So if we would like to, I mean, so I would like to understand like why we are doing it and what quantifies the gain we get out of it. Like what are the problems that we already see that was gonna that RPC over quick is gonna help with. So what is our goal here actually? I mean, I see your slides in the beginning. I didn't get those like really concrete answers, and there is no quantifiable. I cannot quantify the gain. That's what I'm saying. Like, I mean, I just don't want us to work with it just because this is something cool to work with. But we also understand like what is the achievements and what we try to achieve here. So, I just want to clarify those things to the working group.
No, that's absolutely fair. I think I've communicated my own fuzziness on these ideas already. I don't have good answers, and I think that the initial slide I put up that said it's not clear why we would be doing this. That says it all. We don't know those answers yet, and I'm not clear on exactly how I would go about getting them.
Maybe I would like us to actually have more discussions on it on the mailing list, and we try to do what we're trying to achieve and what's gain we're trying to get. I mean, obviously this is, I mean, like I'm super happy to see like people are picking up quick and trying to do a lot of things. We had another discussion, media over quick. This is RPC over quick. These are cool things to do I think, but why? And what do we gain, and what is the problem with existing protocols? So if we understand those correctly, I think we'll be having really good motivation to do that. So please continue the discussion before we jump into conclusion here.
Okay, so that's probably one vote for putting this off until we have a better use case for it. And I think that's a perfectly fair thing to ask for. So
I thought I heard take this to the mail list.
yes.
Okay.
Okay. I've asked to share these slides again, the different set. There we go. Okay, this is an update on RPC of RDMA version 2. Some kind of a status report and summary of the technical issues that facing right now. Just have 11 slides here. Let's see what's my time like. Okay. I've been working on a actual implementation. Both client and server are implemented in very basic form. I haven't been able to implement the V2 credit accounting without flow control, adequate flow control. There are some pieces of the version 2 specification that cannot be prototyped. So I'm kind of blocked on having a flow control implementation right now. And the reason for that is that the text in section 4211 in the -04 revision is basically garbage. I think I wrote it and left in there as a placeholder. as I tried to implement it, I found that it was just not going to be adequate for what we needed to do. And the reasons are on the slide. I don't really need to go into those, but they're here for completeness. So what I want to do instead is implement an actual classic credit-based flow control mechanism in RPC RDMA v2. Go back to having a full 32-bit field that's the credit grant, or in classic terms, the window size. And then we would need a second field that is usually it usually contains a sequence number, but we could also use the number of messages that have been received by the peer since a connection was established, because that's an implicit sequence number. We need to the remote end needs to advertise that number to the sender, so it can the sender can gate its transmission. I did reach out to Jana twice. I was not able to get a response. Martin suggested talking with him. But without that, I just sort of went ahead and built something that I thought would be reasonable. My co-author Dave has looked at this and thinks it's reasonable to go ahead with. We don't have a location in the header message for the second field. That's the only thing that's stopping me from actually implementing it right at the moment. Go ahead. Sahid.
If Jonna has some bandwidth issues that he cannot look at it now, we can find another person if you feel like that's what is needed. We're in a TSB working area, so we should be able to find somebody who understands this flow. So I can take an action point if you think like that is needed.
Yeah, what I'm looking for is some expert review. I'm hoping that the language now in the editor's copy on the GitHub is clear enough that it's just a page or two and will be easy for someone who understands this, the theory here to sit down and look at and go, yeah, that's good. No, that's stupid. Do it this other way.
Okay, let's find somebody who can do that.
Thank you.
Thank you.
There was some complaint on the list a few months ago when I brought this up earlier that we need to be careful not to spell, to be too specific about the algorithms that are being used by the sender and receiver. I hope I haven't crossed that boundary. I hope the language in the document describes the protocol and doesn't really lock either any implementation into a particular algorithm. I sort of need to have that reviewer come back and look at that language and see if it meets his requirements. But he was not able to be here today. As I was looking over the quick RFCs recently published, I noticed that they have IANA registries for error codes and transport properties. And I'm wondering if RPC over RDMA version 2 should do the same, or maybe include other aspects of the protocol, like the message header numbers. That's certainly something we can take that discussion to the list. We don't have to go into that here. So now, what's up for the working group? They're still sort of waiting for prototypes. I think we have a milestone date to deliver this document by December of this calendar year. I'm not convinced we're going to make that because there are so many items in this specification that are new since V1. The credit accounting protocol is one of them, but other things like peer authentication and transfer properties and other things or in particular message chaining are things that I would like to have under our prototype belt before we move forward with working group last call. I'm also wondering whether we should consider the amount of work that's needed on the prototype and the document itself compared to some of the other things that we're interested in working on right now, especially TLS and the revision of RFC 5661. As far as I know, right now the Linux prototypes are the only ones I would like to see a second prototype at least brought to testing events so that we can have some interoperability, some confirmation of interoperability. And I'm wondering if maybe we should extend the milestone farther than just maybe a year, or understand what the priority of this work is, so that we can focus on some of the things that more people are interested in than just this particular new version of protocol. Any comments on that?
No comments.
No comments. Okay, well, I'll ask again on the mailing list. And I just want to throw up this slide for 30 seconds. This is my plan for the prototyping of in Linux. Hopefully I can get this credit accounting protocol nailed down. And then the next most interesting thing I'd like to look at is message continuation. Because I think that's a winning, unique feature to V2 that V1 just doesn't have. It's a big win. And then after I get those under my belt, hopefully we can look at transport properties. And meanwhile, I still feel like peer authentication is underspecified in that document, and I think that needs some expert attention as well. But I think the credit accounting protocol is the priority right now. Once we get a little farther with the prototyping, we can go back and look at peer authentication a little more carefully. Okay. All right, I see two decks here that say hash tree interchange format. I'm not sure which one is the right one, so I'm gonna. They both say July 30th, 5/31/34. Let's see what this one looks like.
Sorry.
Yeah, I don't know what's going on there. All right, well, let's just go with this one. So as longtime hangers-on know, I've been working on various forms of data integrity around file systems for quite some time. In Linux, there's this thing called integrity measurement architecture. They're kind of interested in being able to extend that out from local file systems only to support remote file systems as well. But we began encountering a number of issues with that. Namely, we needed a standard way of expressing the metadata that non-Linux systems could recognize and deal with. And we also hit the problem of some of these systems would have a problem with a GPL-only format. I think I've addressed those issues with this particular proposal. Our use case is code signing, or basically attesting, having a letter of approval for a software component is basically what this is. So the easy part is creating attestation metadata that, you know, a software vendor would basically create a digest over like an executable or a library, and then sign that digest and include the algorithms used to create the digest and create the signature in that metadata, and then attach the metadata to the file content and distribute the metadata with the file content to end users. So, and then the hard part is on the end user system, because applications want to read these executables in small pieces, especially libraries. You know, an application isn't going to want to use the entire library. They're just going to want to use little bits of it. And you know, a linear digest like MD5 or SHA-1, for example, you know, you've got to read the entire file to compute the digest and verify it. And the problem is that that sort of is not real. It doesn't. It's an impedance mismatch, shall we say, with the way virtual memory is managed on end user systems, especially on memory exhausted systems. Certain parts of the file can be purged from memory and that memory reclaimed for other purposes, in which case then, you know, the next time the file is read from untrusted media, it's got to be read as a whole block in order to confirm that the digest hasn't changed. The file measures the same way as it did before. So to resolve that issue, people turn to a tree of digests, often known colloquially as Merkle trees. The only issue with Merkle trees is that they're not a fixed size piece of metadata. You know, a linear hash like a SHA-1 or SHA-256 digest, that's, you know, usually less than 4 kilobytes in size, much less, in fact. And so that's easy to guarantee that, you know, a file system can store that little bit of metadata, but a hash tree can get quite big, like in the hundreds of megabytes. So it turns out that in most legacy file systems and storage protocols like NFS really don't have an easy way to provide sidecar transport for hundreds of megabytes that are not in the primary byte stream of a file. So what do we do about that? If we want to make Merkle trees useful, we have to reduce the amount of data that is stored. So what I'm proposing is just signing and storing the root hash of the tree. And then when the tree is installed on an end, you know, the software distributor would sign the root hash and attach that as the metadata. And then on the end system, you basically reconstitute that tree. And you can either store it on local storage if the local file system can store hundreds of megabytes of sidecar data, or you can cache the tree in memory and use it on demand anytime you open the file. Either one is possible. Whatever you have facilities for, you can choose between the two or a combination. Second, we needed a standard format that's not encumbered. So I thought maybe an X509 certificate might be good for that. We basically put the signed root hash, or we put the root hash in the certificate. The certificate then is signed, so that signs the hash. And then its representation format is DER. We have a standardized set of digest algorithms that are available and represented in the certificates that people recognize and can deal with. So the combination of these two things would give us the kind of letter of approval that we might want to ship with, distribute with software that is installed on end user systems. So I have these questions. I'm not sure this is the right forum for an interactive discussion of these things, but So I'd just like to have people think about this a little bit. Maybe I will take all of this to the list. But the main question is, has this been done before? I'm really not interested in duplicating this, but rather providing something that is needed, but hasn't been done before. Any initial comments on this? Is there another working group where this might be better done, like RATS? Okay, well, go ahead, Brian.
That was a no.
Okay, I think I'm done.
Your work section, or it's just a discussion?
I think the beginning of that was cut off.
Dave, do you have slides for the future work discussion? That was no. There are no slides, I see. Slides. Wow, no.
Okay, I'm speaking.
Hey, Dave. Chuck, you hear me, right?
Yes, I do.
Dave had on the agenda future work discussion. We've already talked about a lot of future work. Is there anything new? What do we have in that agenda? Hold on. Dave? Hold on.
Brian, maybe you can write question in the chat room so Dave can hear it or read it. Sorry.
Okay. Sorry, I missed that. What did you say? I was reading the chats here.
Like
So,
you can write question to Dave on the chat because he's reading the chat.
yeah, but he's not.
If I may make a modest proposal,
Yep.
Maybe we should plan an interim meeting where we can use something like WebEx.
Sure. We don't have a prepared presentation on the future work. There was just a couple of notes in the agenda that was for the Steve, as you noted, the PNFS NVMe and PNFS RDMA work. And I don't have a status on where we left that, and then Dave had a note about ideas to address other needs which are part of our charter but not been given serious attention. My suggestion at this point, it's got a point. Yeah, hey Chuck.
Yes.
We're down to 9 minutes, and I'm watching the chat. Down to 9 minutes. Why don't we take the future work first to the mail list and decide how we want to proceed with it? I don't think we have the people in the room right now that could actually give us a kind of a where we left the PNFS stuff, Chuck.
Well, we have Dave Black. I think he was the last touch.
Yeah, I'm the last person with whom a version of that draft is left. Copious spare time has been limited supply to work on it.
That's information, but not. But it doesn't help me.
If you're looking to put a milestone on a goals chart, that was not information that enables you to do it. I understand that.
So as I recall, there was a tool chain issue there.
Was able to get an XML file and put it into a tool that I can use, and with luck, we won't get bit by the changes to the XML template. A workaround is known, which is just don't send the XML, send them the text. They don't care.
Mm-hmm.
I'm hoping that is what we did. But in any case, the tool chain issue was overcome last time I was able to work on this.
Excellent. Well, meanwhile, I agree with Brian. We should probably move this to the mailing list and plan a meeting with technology that works for everybody.
Getting a thumbs up on the chat. Let's call this meeting to a close, and we'll have several action items to take, some discussions to the mail list, okay? Including the future work discussion. Going once, going twice, sold. Okay, take care, everybody.